Yeah, hello everyone. Thank you very much for coming and thank you for joining online. So as it was said, right now I'm obtaining a position in academia, and this talk will be about the results from my PhD research. And so in this talk it will be an attempt how to connect academic results in all this rapid AI development system and with maybe future industrial real cases. So also I will make a small remark that this talk requires that you're familiar with transformer models. So this very modern NLP models, and that maybe you once in your life have already tried to download models from Hugging Face and maybe try to fine-tune them. So I will assume that you are familiar with this. So the fight of toxicity, I would say here, was rapidly developed since 2021. Several companies tried to somehow fight toxic language on their platforms, and Instagram announced a model integrated into their platform where they can detect toxic messages, toxic responses by keywords, and you can block, hide such kind of messages and users. Also, Facebook introduced kind of like the same approach how to fight toxic messages and hateful messages. So, for instance, if you're a moderator in some group and the system can detect that maybe the conversation is already at very high degree, and it can announce that, please take a look and take care of conversation in your group. So indeed, there can be a problem, unfortunately, in social networks when users can be toxic in conversations or in the comments. And unfortunately, right now, the majority of the platforms, they just blocking this message. But we saw that maybe it can be a nice idea if the message would not be blocked, stopping the conversation at all. But maybe the system can recommend that, your message is toxic, but maybe you can rephrase it like this. Just a recommendation. On the other hand, toxic can not be just only humans, but also can be chatbots. And if the chatbot is trained on some large internet data, it can be, at some case, also be toxic. And there was even cases also from chatbots of big companies. And so in the end, right now, at very huge, rapid development of large language models, indeed, the responses from these models can be indeed quite toxic. So you are very aware of ChatGPT and even of GPT-4. So these models can have different roles. You can assign a role to these models. And at some point, if you assign the role to their different historical personalities, it can become toxic at some point. So I have a link here to the scientific article where this toxicity was discovered and researched in different cases. So you can refer to this article for more details. So right now I will be as this academic data scientist, and I will tell you that if you want to perform textile transfers, so what we want to find out? We want to find out such a function that given a text in some source style and a target style where we want to transfer this text, then we want to produce a new text that will be indeed in a new style that was taken as an input. Also, the content of the text will be preserved as much as possible and as much as needed for the task, and also the text will be fluent. And these three criteria can be assured with some specific functions. So in terms of detoxification, what does it mean in normal language? So we want to indeed transfer style of text from toxic to non-toxic. Also, we want to save the meaningful content of the sentence, of the text. And also, of course, we want to have our text fluent. And so here you can see examples what we want to achieve with our model. If we talk about text and transfer task in general, all approaches that was developed before can be divided into two big groups, unsupervised approaches and supervised approaches. What is the difference? The difference is that if you have only some text-specification corpus, because for toxic language there are a lot of corpus where you have labels that text is toxic or non-toxic, but these texts are not parallel. And you want to somehow to transfer the style, or it can be formal, informal, any text classification task. So if you have only such corpus, and these pairs are not parallel as in machine representative task, that you need somehow to find out some heuristic how you can transfer the style. One of the approaches can be pretty straightforward. So for instance, talking about toxicity case, You can just delete maybe some obscene lexicon, yeah, or you can just delete some bad words and that's it. But in this case, you can lose some content if you just delete the words from your text. Maybe you can try to find a more sophisticated approach, and you can try to find the substitution of this phrase that you want to delete, maybe in some non-toxic part of your corpora. So maybe something with some similarity, you can just find the text more similar to the original text. What also we can use? So we can actually use the power of transformer models, and if we think about the BERT model, one of the tasks at which it was pre-trained, it was masking modeling. So how we can apply it for our case? For instance, we can, so we have an input, some text with some toxic part. We can detect this toxic part with some actually not so sophisticated model. So it can be even just some log regression classification model, just trained on the corpora, and it can already work pretty good. So we can then mask this model, mask this token, sorry, and then we can ask the model to substitute, to find a substitution for this masked part. And actually, yes, as BERT was pre-trained for this specific task, it will find out for you pretty similar to the original text substitution. The only thing is here that we also need to ensure that the substitution is also in the correct style. So in our case, it's already also non-toxic. So we can as well use the scores from classifiers that we did for our first step and re-rank the candidates that the content is similar to the original token, and also the style of this token is also non-toxic. And yeah, so in the end, we can have pretty fluent sentence. So unfortunately, the problem with these models can be that indeed substitution can work not so good. And maybe in the end, we need to substitute not just like token by token, yeah, word by word, but maybe it can be a phrase, so it can be just several tokens. And the task of generating a phrase from a mask for such language models is actually quite challenging task. So yeah, so this can work, first of all, but this can have some drawbacks. So yeah, if we are lucky and if we have such parallel corpus where we can have the pairs of toxic text and natural text, we can fine-tune some large language model for this generation task. And yeah, so you can fine-tune GPT, GPT-2, T5, BART, and any other new already appeared language models. But yeah, so the thing here is that we need to have such parallel corpus. And yeah, so talking about other corpus from different tasks from text transfer, unfortunately, there are three, maybe of them. The first one is Bible data sets that was collected actually throughout the generations, centuries, and even thousands of years, just by translating and moderating the language of Bible to a modern language. And another corpus is changing the formality style. So yeah, actually this corpus is a modern corpus already, but the collection was manually done by the authors of the paper. So toxicity, we have actually a lot of data sets for English language and for Russian, German, Chinese languages, and many other languages, but these are just classification data sets. They have a lot of samples and also different labels about different types of toxicity, but unfortunately they are non-parallel. So in my research, we asked ourselves such a question and stated a hypothesis. So maybe if we collect such parallel corpus for the detoxification task, and if we fine-tune language model based on this corpus, then we can improve the detoxification task performance and achieve quite good results. So the research also was about how to define such a pipeline to collect such kind of corpus. So we want to achieve that for each toxic input, we have 1, 2, 3, several paraphrases. Also, again, the content is the same as much as possible to the original sentence. The style is indeed non-toxic. The new text is fluent text, and we do not want to dedicate the half a year of our personal time to annotate all this corpus. So what we created? A small also remark about type of toxicity. Indeed, if you look at, for instance, jigsaw corpus, there are different types of it, and some of them are quite difficult to handle. So we worked in our research only with 2 I would say, simple types of toxicity, because you can see that there is just a usage of some obscene lexicon or some insults, quite local insults, that can be indeed eliminated from the text, and the content will be anyway saved, but the content of the text is already non-toxic, because if you look at the upper part of this table, if you think about how you can paraphrase it, that it can become non-toxic, you can understand that you need indeed to significantly paraphrase this text and indeed to change the content, because their origin of the text is quite toxic and hateful, and is quite hard to handle. So we selected only those samples, and so we prepared the data set. The text in the data sets of originally labeled for detoxification task can be different. It can be just a sentence or several sentences or even a paragraph. So we separated only sentences. Then we selected sentences that are marked as toxic with our classification model. And also we selected sentences that are not super short, because they can be just, as you can see here, just several obscene lexicon standing in one sentence, and there is no super much meaningful content there, and also not super long, so it will be easy for annotators to paraphrase those sentences. Then we created an annotation task where we indeed asked annotators, so please paraphrase this sentence that it will be non-toxic, it will not sound offensive. So also, of course, we left for annotators option not to paraphrase the text, because indeed it can be just simply non-toxic, so the classifier made a mistake, it can happen. Also, the text can be anyway also with a lot of obscene lexicon, it can be non-meaningful, or if you want to remove the toxic part of the sentence, it can change the meaning too much. But anyway, you can see that here the text field where the annotators should have written their text is just text field. You can write anything here. So we indeed want to ensure somehow the quality of our samples. So then we created the next task where we already can solve a just simple classification task, comparing two sentences and verifying if the content is preserved. And yes, annotators should have answered if the content is preserved or not. If it was not preserved, so we didn't pay for the first task for this sample to annotators. If it was successful actually paraphrasing, that we go to the next stage and check if the style has changed. Again, if unfortunately it was not, so we didn't pay for the sample for the annotators from the first task, but if it's indeed right now already non-toxic, that we are lucky, we have a nice sample for our data set, and the annotators are paid for their job. So in the end, the whole pipeline looked as follows for English dataset collection, and it was done with the local AI platform. So we have these three stages of annotation, and actually, from each stage, the separate corpus can be created, and everything also, the annotation results are also available online. So I will tell about this later. And even then we tried to expand this collection pipeline to other language, so for Russian language, and it was actually not so difficult, didn't require so many steps. So firstly, of course, you need to have labeled toxicity classification corpus for your language, but if you have such, then you can just adapt the interfaces of the task for your language. You can just translate it. Adapt also training tasks for annotators, and then create corresponding tasks. And theoretically, it can be used for any language. So as a result, we have publicly available two corpus for text detoxification for English and Russian language, and it's about of several thousands of sentences, and you can see also the cost that was used to collect such corpus. So then what's next? We need to fine-tune language models based on this corpus. And just here are the results that you can take a look at what we wanted to have and what samples you can observe in our data sets. Also, how to evaluate the models that we will create actually is also not a trivial question because it's not just machine translation task or some classification task, it's text generation task, and it requires also a specific amount of work. So as you remember the definition of text style transfer, we have these three parameters, and actually we want indeed to ensure these three parameters in our evaluation metrics. So what we can do for ensuring style transfer accuracy, we can as well use a toxicity classifier just fine-tuned on some toxicity classification data set. How to evaluate content similarity? We can use cosine similarity between embedding of the text, and for this we use LabCI embeddings. Also, fluency is also a non-trivial actually metric. So firstly, we thought about to use perplexity, but unfortunately it has quite low correlations with human annotations. So we use classifier for this, trained on language acceptability corpus. So really I recommend this approach to ensure the quality of your text, and also to have a single measure for all these three metrics. We accumulate it as geometric mean. So we multiply sample weighs these three parameters. So yeah, for instance, if you have 1 in cell transfer accuracy, so indeed the cell is non-toxic. If you have 1 in content, so content is saved. If you have 1 in fluency, that you have perfect sample. But if one of the metrics is 0, so unfortunately the sample cannot be shown to the user, yeah, potentially, and it should not be considered as a good sample. And just then calculate mean between all of them. And to evaluate similarity with human annotations, yes, so with this written by annotators paraphrases, we calculated blue metric. And also, we actually tried to perform manual evaluation. So actually, the idea is the same as for annotation. I won't stop so deeply here. But yeah, so if you want to check the quality of your text generation task, it's also nice to have manual evaluation. So it will be the point here. Yeah, so the results. So you have here a pretty standard table of results from academic paper. Indeed, if you take a look on different baselines, quite of them are pretty simple, but also actually have pretty nice results. What you can see is that our models perform way better than all previous baselines. And that was automatic evaluation. So if we take a look on manual evaluation, where we manually checked the samples from test sets, you can see that the difference is really huge. So our model has pretty nice similarity and very high fluency, maybe sometimes not catching all the types of toxicity, but yeah, in general, it performs very nice. And you can see also here the examples how different models can paraphrase, can detoxify the toxic sentences. So yeah, if you just delete some words, the content can be missing. Conditional BERT model can paraphrase and can find substitution quite maybe not accurate. Also, another baseline PyData here, it's also pretty nice, but also, if you can see on the second example, sometimes paraphrases can be anyway quite similar and anyway a little bit toxic to the original sentence. But our model saves the content very precisely, and you can see that this is very nice non-toxic fluent sentences. And also I have the tables, the same table for Russian language, so also our models outperforms all the baselines. If you look at manual evaluation, you also can see the huge differences between the scores, and if later you want to take a look, and if you're familiar with Russian language, you can also read the samples as well. Yeah. And then, actually, when we did our research, another question arose. So we have this corpus for Russian language, and also we even dedicated our time and resources to collect for Russian language. But what about other languages? So what we can do for them? Or maybe if we can train the models that will perform detoxification for any language, it can be a multilingual model with such a task. Actually, it's very non-trivial also question, and so the research is still ongoing, but I will share with you a recipe how you can transfer the knowledge of detoxification for other languages. So first of all, if you just want to achieve detoxification for your language, so what you can simply do, you can use a translation model or detoxification model, English model, as an API, as a black box. So you can just translate your input with some Google, DeepL, any other API translation models, and then you can detoxify the sample with, for instance, our English detoxification model, and then translate the answer from a model to your language as well. So yeah, you can see that it actually works pretty nice already. Unfortunately, there is a dependency to some external API here for the translation or for detoxification, and yeah, so it's dependency on some other models. Also, what you can do, so you can actually translate the corpus, and also it's also a dependency on the one hand, but it's also a dependency in one run, so you can translate the whole corpus, and then you can also train your detoxification model based on this corpus. So the trick here is that, of course, maybe this corpus will not cover the whole toxicity types that are present for your language, because, yeah, even if toxicity can be on one hand the same, different language can be different types of toxicity, different expressions for this, so it maybe not cover all the cases, but anyway, for their baseline model, it can be also pretty nice. But if you want to get your hands dirty, what you can do, so you can use adapter training trick, where you can insert adapter layer between encoder and decoder of your language model, fine-tune this adapter, and the trick here is multilingual language model. You can fine-tune the adapter layer only for the detoxification task, and as the model already is multilingual, and adapter is fine-tuned on the detoxification, even if it's only English detoxification, anyway, it can handle their input in other language and will produce the already an output in your language. So yeah, it can be your model specifically allocated on your server, on your computer, on whatever you are using, and it can be, training an adapter is way easier than training, fine-tuning the whole large language model. Yeah, from this point, actually, the last question left is that, of course, with all these advances, you are sitting and thinking, can actually ChatGPT perform text detoxification and replace 2 years of my research? So let's take a look. I tried the examples which were present in this presentation and feed them to ChatGPT, and you can see the results. Maybe several seconds to read them. So what I personally think about this, of course, it performs detoxification nicely, because this model was trained and fine-tuned and adjusted a lot to perform just in generally very polite and non-toxic text. But this is actually a thing. So if you read these sentences, they are very, very polite. They even too polite, in my opinion. And moreover, you can see that the model can hallucinate. It can maybe add in some additional sentences, additional text. And if you think about how to use this model as just a black box, an API to feed toxic text and to feed out, just non-toxic paraphrase, it can be actually challenging to use. So the use case, as I thought here, is that if you want to just indeed ensure that your chatbot is non-toxic, ChatGPT can be really quite a solution, and these sentences will be very polite. But our research, so I will emphasize this, it was not transforming from toxic to polite sentences, but from toxic to non-toxic. And actually, this is a difference. And when I saw then how it can be applied for current advances for training large language models, so if you think about how to pre-train your large language model, your chatbot, or for any other usage, so some big language model, and if you want to use some open source data or even data, and there can be a case that maybe some of the texts are toxic, some of the samples, some of the part of the text are toxic, so actually our model is perfect to do this pre-processing and just to filter this toxicity. So you can just simply detect if the sentences, some sentences are toxic, and apply our model, and the thing is that it will save the content very, very much and very, very accurate. So the usage of, and there will be no addition of any additional text or noise. And also, if you think about, maybe later it will be indeed a chatbot or some model with human human input, so maybe some question answering system or whatever. And there can be a risk that even the users can be just toxic just because they want to be, or they just want to stress your model. But you also can have this filter that you are trying to detect toxicity from the user and also detoxify the input from a user. And again, that the content will be saved as much as possible, so there will be no additional noise, or there will not be a losage in any details. And maybe in the end, you also can use a model to have this clear filter of toxicity and to show already user a non-toxic output. So actually, talking about what is available online. Actually, everything is available online. So there is a QR code and a link to GitHub repo where you can have all the list of the models, all the data sets available, from annotations, from fine-tuning. So we have sort of models for Russian and English language, and also we can even have several demos. If you are a fan of Telegram, you can also try our bot, and you can also test our models. And also there is, in GitHub repo, there is a list of all papers that we wrote during all these years. Of course, it was a huge effort from our team. It was really dedicated work for almost 2 years, and I really thank everybody who helped me during my research. And so actually that's it. Feel free to contact and feel free to share your feedback, what you think about our results. Thank you very much.
Thank you so much for that excellent talk. We have a few questions on Slido. I'll just go over them. First one, is detect plus substitute fast enough to alter user texts live while they are posting it?
So you mean like approach just to, again, like to use this masking language modeling? Yes, just to check if I understand the question correctly. And if the speed of this model is, the other models are quicker than just sequence models. Am I understanding correctly the question? Okay, so I'm assuming that I understand it correctly. Awesome. So actually it's not, I would say that it's not quicker because of this re-ranking step. So if you just ask the model to make substitution for your mask, it indeed works quite quickly. But you need to do this re-ranking about the toxicity score, and you need to either run classifier as well as during this inference step, or you need to use these toxicity scores. But anyway, this ranking step can be quite challenging and quite time consuming. So if you have, just to mention, so we trained base version of BART and T5, so they are not of much memory required, and they perform quite quickly. So I would say here that our models perform with quite adequate speed and already can be used.
Super. I'm not sure if we have enough time, but let's try sequentially. Thank you for the talk. I can see your model being useful for Twitter. Now the question, do you think text style transfer can be used as a data augmentation technique? Oh yeah,
so it's a very nice question, and I'm sure that it can be used, yes, definitely, and indeed through, so even through, to have in a data set, in training data set for large language model, to have several samples in different styles. So it can very perfectly augment your training data set. Moreover, if you have such a data set with already several parallel pairs, for instance, you have a sample in formal or in formal style, in toxic and non-toxic style. And even your large language model can perform already several tasks simultaneously, so it can be really reused for several tasks and not should be fine-tuned for additional tasks. So just thinking about this green NLP point, so the reusage of training data set and the reusage of language models is right now a trend, and so I think it's a very nice use case for our model as well.
Excellent. I'll try to combine two questions because I think they're asking similar things. How do you address sentiment while detoxifying the sentence in your research, since swearing can be used in a positive context as well? And then the related question, what should happen if a sentence is just an insult without any other content?
Yeah, so yes, great question. So about the sentiment, so I don't remember if I have the samples in this presentation. So the thing is that indeed the sentence can be toxic and it can be negative. And when we transfer in style from toxic to non-toxic, we're just deleting this toxicity style, but we do not delete the sentiment. So still the sentence can be in negative sentiment. And for us it was also important. So even we have some training examples for annotators that we should not try to make the sentence more positive or more nice. So we just need to eliminate this toxicity style. And sorry, the second part.
What should happen if a sentence is just an insult?
So as is showed, so even in the processing step, we tried to eliminate from candidates to rephrase such text where there is just a concatenation of several obscene lexicon, just insults. So the thing is that in such a text there is no meaningful content, and unfortunately we cannot detoxify is that it will bring some content. So of course, yeah, the thing that should happen to such samples is just to delete all obscene lexicon. It will be just empty string, unfortunately. So yeah, actually, I can maybe link here. So also from previous ACL, there was a nice paper called positive framing. So I call this model a model who has several sessions with therapists. So it's indeed, if you have just very rude sentence, so the nice thing to say, yeah, I just don't like your opinion, because usually people write such comments when they disagree with something, they're very angry. So yeah, I don't like your opinion, or I disagree with this, or so you can just substitute, so yeah, huge, only obscene lexicon samples with just key phrases, and it will be already enough.
Cool. Another question, so the many questions. I think it's a very engaging talk. Do you think it would be possible to use a cyclical consistency loss, like cycle GAN, to train the style transfer without parallel data set?
Yeah, so I would say that you can find, if you don't have parallel corpus, you can find a lot of heuristics that will work pretty nice. But unfortunately, a lot of research was done that it do not perform so nicely when you have parallel corpus. So it's just, unfortunately, a case. So a question for us, for instance, right now, as you saw, so for our corpus, we collected several thousands of samples. But the thing it can be is that actually we don't require so many thousands of samples. Maybe it's enough to have 1,000 or 500, but the samples can be just different, covering all different types of toxicity. So for us, it will be like next step of research, how we can define, how we can reduce the corpus collection. But yeah, so heuristics can be different. Also, you can try to embed style and content in different embedding space, and then try to sample style and text and content from this space. But unfortunately, because we do not have such nice compression of text, so not precise compression of text into embedding space, it's still not so accurate.
Okay, maybe one more. Should we really whitewash sentences like your examples are idiotic? Language can be quite nuanced and individual.
And this is absolutely true. So I have actually a lot of questions about this. And the thing is that, of course, you need to think about your use case. So I'm talking about, yeah, so this is a model. We created it because we had a request how we can filter toxicity from chatbots. And then we were developing our model, we were developing our use cases where we can apply this. But if you think that maybe some cases should not be detoxified in your application, or for instance, it's okay to have some obscene lexicon in your domain. Also, there can be a case, so domains are different. For instance, in some gaming domain, some lexicon is indeed non-toxic or usual or etc. So just you need to think about how you will apply this model, what should be applied from the corpus. So yeah, just you need to think really about your use case.
Yeah, thank you so much. There are a few more questions, but maybe you can take them offline.
Yeah, thank you very much.